This is the prerequisite review for Section 3.1, Quadratic Functions and Applications. This worksheet will cover 5 objectives, and we'll begin with objective number 1, solving quadratic equations. In number 1, you can see we have 2 binomials multiplied together that equal 1. So either x minus 5 is equal to 0, or x plus 1 is equal to 0. One of those caused the multiplication to equal 0. So we will add 5 to both sides, and we have x is equal to 5, and we will subtract 1 from both sides, and we get x equal to negative 1. In number 2, as you can see, we have a quadratic that we will need to first factor. And of course, we have 2 numbers multiplied together to equal a negative 15 and add them together to equal a negative 2. And as you can see, this will be a minus 5 and a positive 3. Let me write that a little bit neater. So in this case, either p minus 5 equals 0 or p plus 3 equals 0, and p equals 5 or p equals negative 3. Okay, moving on to number 3, we'll go ahead and factor that again. Another quadratic we have to factor, 2 numbers that multiply together to equal 16, and when we add them up we will have negative 10, and of course we have a negative 8 and a negative 2, so either w minus 8 equals 0 or w minus 2 equals 0. So w is either equal to 8 or w is equal to 2, or both. Okay, moving on to objective number 2. Here we will practice our function notation and also again finding x and y intercepts. So the first question is find the values of x for which f of x is equal to 0. So here we're going to be setting f of x equal to 0. So we will have x squared plus 4x plus 3 is equal to 0. And factoring that, we have an x plus 3 multiplied by an x plus 1. And then, let me move this over to the right a little bit so I have some room. So then either x plus 3 is equal to 0 or x plus 1. And we have x is equal to negative 3 or x is equal to negative 1. So again, same as objective number 1, but now we are using function notation, and keep in mind our f of x is equal to y. So we would just let f of x be 0 and plug that in there. Now we want to find f of 0. So here we have f of x equals x squared plus 4x plus 3. And so f of 0, everywhere there's an x, we're going to write a 0. And you can see here that we end up with f of 0 is equal to 3. Whoops. Okay, let's go on to objective number 3, solving quadratic equations by the square root property. Okay, so this is when we do not have an x term. Okay, so we just have an x squared term and a constant. So in this case, we are going to take the square root of both sides. I'll rewrite that down here so that I can show that. So if we have x squared equals 100 and we're going to take the square root of both sides. Of course, we have to take plus or minus the square root of the other side. So we come up with x equals plus or minus 10. And you can put that in set notation, just like we could have done up here, -3, -1. And we could have done the same for these. And you can place them in any order. I'll show you that here. We've got 8 and 2. So you can write it like that. Okay, let's take a look at number 7. Here, the first thing we're going to do is divide both sides by a -2, and we end up with m squared is equal to -25. Now, this will be the first time that we come up with imaginary numbers, okay? So we are not no longer in just real numbers. So we are also including imaginary numbers. So imaginary numbers are now possible. And so we do need to talk about that. And so we have this number I, and I is the square root of -1. So if you actually square I, you would square that square root, and you would get I squared equals -1. Okay, so we will be able to take that square root of -1 out and make it an I. So now we are going to take the square root of both sides here, and we have plus or minus. So I'll write this detail now. This is plus or minus the square root of -1 times 25. So m is plus or minus 25 comes out as a 5, and the square root of -1 is I. So here we have plus or minus 5i. Okay, looking at number 8, as you can see, let me write that out. So let's see if I can move this over to the left just a bit, and I could even move this a little bit just so we have little room. And so now we are going to, I'll write this out so I can show you that we are going to take plus or minus the square root of both sides, plus or minus that right side, and we have p minus 5 equals plus or minus 3. So I'm going to add 5 to both sides, and we have p equals 5 plus or minus 3. Now 5 plus or minus 3 gives us two numbers, okay? So we do need to make sure we know that. This is p equals 5 plus 3, which is 8, and p is equal to 5 minus 3, which is 2. So our solution set is actually 2, 8. Okay? Okay, now we're asked to find the value of n so that we have a perfect square trinomial. And this is really nice practice, because what we want to do is state what b is. Probably don't even need this. So n is, to make n a perfect square trinomial, we are going to take half of b and square it. That's what n is. So n is actually 1/2 of b squared. And I should probably put that in the margin right here so that students know what n is. So we're going to go ahead and write that b is equal to -6. 1/2 of -6 is -3, and -3 squared is 9. So n, therefore n is 9. So a perfect square trinomial here is equal to x squared minus 6x plus 9. And what is that perfect square? It's x minus 3 all squared. Let's do the same here for number 10. B is equal to 8. 1/2 of 8 is 4. 4 squared is 16. Therefore, n is equal to 16. I did that so that I could say that this was t squared. Whoops. T squared plus 8t plus 16, and that's equal to t plus 4 squared. So we created a perfect square. I'll just leave that. Okay, let's go on to completing the square. This will give us a little bit of practice. So we will solve by completing the square and then apply the square root property. So what we are going to do is we are going to just keep this part, and we're going to subtract 15 from both sides. That's kind of our best bet. Then we can see that b is equal to, let me write that out on the right side. We can see that b is equal to 8, and 1/2 of 8 is 4, and 4 squared is 16. So for this problem, we need to add 16 to both sides. So we have t squared plus 8t. Let me write that negative 15, and we're going to add 16 to both sides. Now we have a perfect square trinomial, and we have t plus 4 squared is equal to 1. Okay, so now let's go ahead and take the square root of both sides. And we end up with t plus 4 equals plus or minus 1. So we know that t plus 4 equals 1, or t equals negative 3, or we have t plus 4 equals a negative 1, so we have t equals negative 5. So our solution there would be negative 3 and negative 5. And we could write that here. Okay. Okay, let me just kind of circle this. Okay, and then our answer is here. That is our solution. I'll put that right there. Okay, let's do the same thing. We want to have b is equal to 6. 1/2 of 6 is 3. And 3 squared is equal to 9. So that is actually what we are going to add to both sides of the equation. So we will have x squared plus 6x, and of course we have that negative 16. And here we will add 9 to both sides. And now we have x plus 3 all squared, and that's equal to negative 7. So now we're going to take the square root of both sides. That is really messy. And we end up with x plus 3 equals plus or minus the square root of negative 7. So x plus 3 equals plus or minus I square roots of 7. So now we have two different equations. We have x plus 3 equals I root 7, and x plus 3 equals the opposite of I root 7. We will subtract 3 from both sides. And we will have negative 3 plus or minus I root 7. Okay. Now let's go ahead and have some practice with evaluating functions. So this is quite a nice review. Here we are going to go to the g function, and everywhere there is an x, we are going to write a 2. And of course, we come up with negative 11. G of 0, that's the opposite of 0 squared, minus 4 times 0 plus 1. And we come up with g of 0 is equal to 1. F of negative 6. So now this time we're going to the f function, and everywhere there's an x, we're going to put a negative 6. And here we come up with a negative 38. Okay. Now we're going to talk about the domain and range of a function in Objective 5. So as you can see, our x values start way out here at negative infinity, and they go all the way to 3, and we want to include it. So here the domain will be negative infinity going all the way to x equal to 3. For the range, we want to start at negative infinity, and we want to go all the way up to 5, and we are going to include it. So we have negative infinity all the way to 5. Looking at number 18, our domain, as you can see, we are going to start at x equal to negative 4 and go all the way to x equal to 4. So we are going to have negative 4 to 4 and not including x equal to 4. And then we have the range. We will actually start at y equal to 2 and go all the way to y equal to 5, but we don't want that 5. So that is, y equal to 2 to 5 and not including 5. And that concludes this worksheet.